Hello Internet, my name is Quinn and this is Blondihacks. Well, this is year 8 for me of doing beginner focused machine shop content and year 10 for me for the machine shop and model engineering hobby in general. I think that puts me in an interesting position to give people advice that are just getting started because I've learned a few things here, but I'm still kind of a rookie in machine shop work in general. And so I'm still close enough to the beginning that I remember the kinds of mistakes that I made and I can recognize those mistakes in others, but I've been doing it long enough to see the kinds of patterns that develop in the questions that I get asked from new folks and also the kinds of mistakes that I see people making. So I want to hopefully summarize some major points that I've noticed over the years in this video. So let's go. I need to start by setting the stage for this potentially controversial video. I'm going to say a lot of stuff, as I'm prone to doing in these videos, and it's all my opinions, and my opinions only. And some of it might make you mad, and that's okay. Don't be mad in my comments, but you can be mad. The important thing to take away from this is that despite what social media would have you believe, real life is all about nuance and context. So I'm going to say a lot of stuff that is actually in opposition to things you see me doing. And when I do that, I'm first of all going to enumerate those hypocrisies because it's funny, but also because I want to give you the context for why I might tell you to do something differently than you actually see me doing it. Because again, I'm 10 years into this journey, and if you're watching this, I'm presuming you're earlier than that, and you got to learn to walk before you run, and I'm going to show you the reasons that I believe these pieces of advice are good for you. But again, if I say something that is in opposition to what you do and you enjoy what you're doing and how you're doing it, awesome, keep doing it. There is no wrong way to hobby. As long as you're having fun and you're staying within your budget, then it's all good. Beginner mistake number 1, don't buy carbide tooling. Oh, you're mad already, aren't you? I know, I heard all the caps lock keys go down. Okay, allow me to explain. Obviously, carbide tooling is extremely useful and it's critical in modern professional machining. However, there is a time and place for carbide, and I think it's important to understand what it's good at, what it's not good at, and what it can and cannot do for you. The specific beginner mistake that I think a lot of folks make is they dive deep into carbide on day 1 of their hobby machining journey because they see the big kids using carbide, all the pros use carbide, it must be, quote, the best, right? And I think they also are intimidated by learning to grind high-speed steel tooling, and so they feel like carbide is going to be a shortcut to skip over that, to not have to learn this critical skill. This is kind of a flavor of a problem you see in a lot of hobbies, whether it's racing cars or photography or whatever. There's always that kind of prosumer person who wants to buy their way up the learning curve. You know, you go to a photography class, there's always going to be someone who shows up with a $5,000 camera body and 10 grand worth of lenses, but the instructor is going to hand you a 35mm point and shoot and start teaching you about lighting and composition, because it turns out that the gear matters way less than you think it does. And there's no substitute for learning the skills. The gear isn't going to buy you out of having to learn the basics. But before we get to that, let's talk about what carbide is actually not good for in a hobby shop. Carbide is engineered to solve a very specific problem: heavy production machining, material removal rates on extremely rigid machinery. We're talking about modern high-speed CNC machines with 40,000 RPM spindles that weigh 6 tons, and they can do incredible things with very heavy tooling. Or modern manual lathes that do big heavy work on drill pipe and paper mill rollers and those kinds of things. Again, in those industries, time is money and material removal rate is money, and anything that can increase the rate of material removal up to the limits of the machine is going to be worth the money. However, up to the limits of the machine is critical there. Carbide tooling in general is quite blunt because it's designed to hold a cutting edge in extreme conditions for as long as possible to reduce costs. And they're designed to be used on extremely rigid machinery with a lot of horsepower and a lot of torque that can handle those material removal rates. None of that describes your shop. Your shop probably has a 1 horsepower 10-inch swing lathe in it that is not going to be engineered for carbide tooling. Now again, everybody relax. Context and nuance. That doesn't mean there's no place for carbide in your hobby shop. You see me using it all the time, right? This insert here is a go-to of mine, this little triangular insert. This is actually an insert designed for cutting aluminum. I'll put a description of this insert down below because people always ask which one it is. But because it's engineered for aluminum, it's got a very sharp edge on it and a very high top rake on it, unusually high for carbide. And those two properties make it actually a pretty good mimic of high-speed steel. So it works quite well on small hobby lathes. And of course, you see me using insert tooling on boring bars, medium-sized boring bars. It's a really good option there because it saves you having to grind an enormous piece of high-speed steel into an L shape to make a boring bar. So it's a great option there. But that leads me to the next reason that carbide insert tooling is not necessarily a great fit for a hobby or model engineering shop, and it's the kind of work that you're doing. If you're doing heavy material removal with CNC or heavy job shop manual machines, you're doing generally similar kinds of operations. You're doing a lot of facing, a lot of turning, basic kinds of operations like that. You don't necessarily need a lot of elaborate tool shapes. However, model engineering is very, very different. You're working on small parts in tight spaces, a lot of very intricate details. You're doing a lot of O-ring grooves. You're doing special organic shapes because you're trying to mimic castings. You're doing a lot of very different kinds of operations. And for that reason, you're going to have to learn how to grind high-speed steel. This is my first order storage for my lathe tooling. So everything you see here in a holder is stuff that I use every single day. And that's both ends of each of those. Every single one of these pieces of high-speed steel has a tool on it that is a completely different shape and has a shape on both ends. And over here, this little pile is stuff that I also use very frequently, not quite frequently enough to dedicate a tool holder to it, but often enough that I need it right here in this top drawer. And you can see this is a huge pile of additional pieces of high-speed steel, again, with all manner of weird shapes on them. All kinds of radius and grooving and O-ring cutting and snap ring grooves and internal and external threading and all the weirdness that comes up on every single part in model engineering. I mean, just for basic turning alone, I have probably 10 different tools in here for different materials because I'm working in aluminum and steel and stainless and tool steel and brass on a daily basis. You're not just machining 4140 all day like a job shop might do. So you need all different top brakes for all of those things. And you're working in very tight spaces a lot. So I have dedicated turning tools for working really close to the tailstock. I've got turning tools with all different clearance angles on the backs of them for different types of tailstocks. Because again, you're working in tight spaces, you're constantly customizing the setup to the exact part that you're making. The point of all of that is to say that you cannot avoid learning to grind high-speed steel in a hobby shop, especially in model engineering. You are going to have to make all of this weird tooling sooner or later, and the sooner you do it, the better you're going to be at it. And if you tried to do all of this stuff staying only in the world of carbide, don't get me wrong, carbide insert tooling can do all of these jobs. But if you were trying to avoid high-speed steel with all of your might, and you invested in all of the stuff that you would need to do all of this, all of the different insert types and coatings and chip breakers, and all of the different special insert holders and tooling holders that would be needed to hold all of those different inserts, you would be in for thousands of dollars by the time you had all of this. And you could buy another machine tool with that money. But this right here is like 10 bucks worth of high-speed steel from yard sales. A couple of pieces of high-speed steel, you can get them for free, heck, at an auction buying something else. There's going to be a couple chunks of it in the bottom of the box, and it will outlive you. You can regrind it infinitely into any shape you need, and it's tooling for life. Well, it appears, Wyatt, that my hypocrisy knows no bounds. Let's talk about face mills, and particularly insert tooling face mills. Beginner mistake number 2 is don't buy face mills. Now, again, context and nuance, let me explain. Don't go and buy a great big 6-inch multi-insert face mill. I think a lot of beginners do that because, again, you see the big kids do it on YouTube. And I think a lot of beginners have this urge to have a tool that is big enough to cut every surface in one pass because, again, that's what you see the big kids doing. However, there's actually no need to ever do that. If you need to create a big flat surface, you can do it with a 1/2-inch end mill. You just go back and forth across that surface and you've created a flat surface with a small end mill. And that small end mill on your lightweight hobby machine is going to cut much better. You're going to end up with a better result. Small diameter end mills are also less susceptible to problems with nod or tram on your mill. If your mill head is a little bit crooked in any direction, that error is largely canceled out by making lots of passes. If you're making multiple passes on a surface with a small end mill, the average flatness of that surface is determined only by the slides on your milling machine and not by the tram or nod in your head. Now, you might have some barely detectable undulations if your tram or knot are really bad, depending on which direction you're cutting in. I've got a whole video on mill alignment if you want more detail on the effects of that. But the point is, small diameter cutters are going to basically average out that error for you. If you go and buy a giant 6-inch face mill with the intention of cutting big surfaces in one pass, now the alignment of your mill matters a great deal. But more importantly, your hobby mill does not have the torque or rigidity to properly run a face mill that big, and so you're never going to get good results from it. The traditional hobbyist solution to this dilemma is the fly cutter. A fly cutter is a way to get a large diameter surface cutter that's very low tool pressure because it is a single point cutter. It's a spinning lathe that you can move across your workpiece. So fly cutters have been used for 100 years in hobby engineering for this purpose. However, fly cutters have some pretty severe limits of their own. They are not rigid, so they can only handle very, very light cuts, and they are very, very slow. Because they are a single point cutter swinging around, you have to have a very slow feed rate in order for that cutter to get around for another pass before the table advances. So you need to run your power feed extremely slowly, or metallic ore help you if you're trying to hand feed a fly cutter. That is not a fun job. So luckily we live in an exciting modern age and we have some other options if you don't want to do the fly cutter or the 1/2-inch end mill for flattening large surfaces. Now I used to recommend shell mills, and I think these are still an okay option. However, I don't tend to recommend them as much anymore for one main reason. These create nice flat surfaces on smaller machine tools, and they're pretty reasonably priced. They're not too expensive to get into. The problem with them is that they are very complicated cutter geometrically. This is one giant piece of high-speed steel with all manner of elaborate cutting edges ground on it. And if you dull or chip this, the entire cutter is essentially ruined, and it's virtually impossible to regrind it. And that is why you don't see me using this one anymore, because I dropped it one day and I dinged a corner on one of the cutting edges, and now it just doesn't cut well. And yeah, so this is an expensive tool and it's easy to scrap it essentially. So I don't tend to recommend these anymore. But nowadays we have small diameter insert face mills. These are both from Shrum Solutions. As of this recording, he's been having some trouble with his online store, so I don't know if these are currently available, but hopefully they will be again soon. These are what he calls his tri-fly, and they are, well, they're what the name implies, they're kind of a 3-point fly cutter. So they solve a lot of the problems of the fly cutter in terms of feed rate, while still remaining quite low tool pressure, and they're not too large in diameter. Like this is a 1-inch cutter here, and I think this one is 2-inch, something like that. But that's okay. Like with this guy, I can take fairly light cuts with this and it's okay. This guy, I can take pretty heavy cuts on my little mill, and it does save you some time over a 1/2-inch end mill. So these are a good option as well. But if you can't get these, or these are no longer available, again, a 1/2-inch end mill is really all you need. Just make more passes across the surface. Beginner mistake number 3, don't use flood coolant. This is one of those things that enthusiastic beginners often rush to set up on their shiny new mini lathe because, again, they see the big kids using it, and it's a cool looking thing on camera. It looks very dramatic and it looks very professional and serious to have flood coolant on your machines. But the reality of living with flood coolant is very different than the enjoyment of watching it on camera. If you're not familiar, flood coolant is a molecule that is hydrophobic at one end, hydrophilic at the other, allows oil and water to mix essentially like soap. And when you flood the cut with that, the oil part of it improves cutting action and the water part of it reduces temperatures because water is an excellent coolant. So a question that savvy beginners often ask is, why doesn't flood coolant cause rust on the machines? Because there's water in there. And the answer is it does. It absolutely does rust your machine. And so what you don't see YouTubers doing when they show flood coolant is frequently during the day or after every cut even, you have to clean the machine completely. You have to get this stuff off of all of your machined surfaces when you're done. If you don't, you will get rust. And even if you do, you will get rust. The reason I have this jug here is because I tried it myself. This was one of the beginner mistakes that I made, including all those other ones that we just talked about. Those are all mistakes I made too. And you can see that it's full because I tried it for a little while on my milling machine, and I got rust almost immediately between the bottom of the vise and my mill table. I started getting flash rust, and I started getting flash rust on the top of my vise as well. and it really wasn't doing anything for me more than brushing cutting oil onto the cut if it's going to be a particularly aggressive one. And that's the key right there. Flood coolant is the carbide of cutting oils. It exists for big industry because the kind of work that they do, it's essential. They cannot do what they do without it. Nobody likes flood coolant, right? They use it because they have to for the material removal rates that they require for their business to be viable. So they have to live with the negative side effects of flood coolant, the rust and the mess and the cleanup that's required and all of that. They live with that because they have to, not because anyone likes doing that. So you in your hobby shop taking 30 thou passes in brass, you don't need this. If you watch my channel, you know I cut 90% of the time completely dry because it's fine. It's easier to clean up. And if you're not pushing the cutter, nothing's going to heat up very much and it's just not a problem. You'll see me using WD-40 as a light cutting oil in aluminum and occasionally brass. In aluminum, it helps keep the aluminum from galling up on the end of the tool and building up on it. And it helps with drilling and tapping, obviously, especially in brass. Taps can get stuck and snap in brass. A little bit of WD-40 helps with that. And then you see me brushing on cutting oil for tough cutting materials like tool steel where things are going to heat up and the material doesn't like to cut if it gets too hot. But that's really it. Brushing on cutting oil occasionally in certain situations is more than enough for anything that a hobby shop is going to do. Now again, nuance and context. If you set up flood coolant because it's neat, it is kind of a neat system. You got your compressed air in there and all the plumbing and stuff, and it's kind of looks cool, and that's fun for you, great. I'm not going to tell you not to do that if you're having fun, but just understand if you haven't done this yet, you really don't need it, and you'll probably regret it. If you really want to go down that road, another option is flood oil. You don't have to use water-soluble coolant that's going to rust your machines. You can also set up a flood oiling system. That's less popular in industry for lots of reasons. Cost mainly, because obviously large quantities of cutting oil is a lot more expensive than this stuff. But if you really want to go down that road, that's another option. Beginner mistake number 4, don't buy tooling on Amazon. Yes, I'm aware that my video descriptions are literally full of the Amazon affiliate links telling you to buy tooling from there. So let me provide you some context there. Amazon has broken the way people shop. People used to know that you can go to many different stores and many different specialists for all different types of things, and that you went to a specialist for specialist things because they would know what they were talking about and they would care about the quality of those things. Now everybody just goes on Amazon apparently to buy everything. And whatever, if you want to buy your toilet paper there, that's fine. But when you get into hobby machining, one of the things you need to learn is how to shop. Or maybe relearn how to shop, because this is how we all used to do it. You need to find the specialists in your area or online and learn to buy things from them. This is a little bit tricky in machining as a hobby compared to other hobbies because there aren't so many vendors dedicated to this hobby. So you're going to need to interact more with actual industrial suppliers. Traditionally, machine shop tooling was supplied only through wholesale dealers who sent a rep to your shop, and that representative worked with you to sell you specific tooling. And that's still the way it works in industry. However, nowadays there are lots of industrial tooling suppliers who will sell directly to consumers. So places like MSC Direct and McMaster Carr. And there are similar places in Europe and Asia as well. The key for the hobbyist is to understand when this matters and when it doesn't, because there's lots of tooling that you can buy the cheap stuff, and honestly, it's perfectly fine. Buy the cheapest 1, 2, 3 blocks on Amazon. I've bought multiple sets of those, and they seem to all be fine. I've inspected them, and they seem to be just fine, certainly for hobby grade work. But when it comes time to buy end mills, for example, you have to buy quality end mills. Anything that's for sale on Amazon is going to be garbage. And that makes a huge, huge difference. If you're spending less than $150 on an end mill, it's garbage, and you need to be going to a proper industrial tool supplier for those. Other areas where quality really, really matters, twist drills, taps and dies, those kinds of multi-point cutters, quality absolutely matters. The cheap stuff is going to break more often, it's going to wear out quicker, it's going to cut poorly, it's going to cut off dimension, and you're just going to not have a good time. So a good set of twist drills that you spend real money on is going to last you forever. Same with taps and dies. If you buy good tooling in a hobby shop, it's going to last forever. Because it's a low demand environment, the tooling lasts a really long time. So you can spend $150 on that end mill and it's going to last you 10 years. as long as you don't drop it. Okay, but the elephant in the room, why do I list all that stuff in my Amazon affiliate links? Well, obviously because it helps fund the channel. If you click on one of those links, I get a little funding from that. Even if you don't buy the thing that I'm linking to, by the way, I still get a little something from that if you start your session with those links. But also I think it's helpful to see the range of stuff that you can buy. If you're new to hobby machining, the range of tooling can be very intimidating and very bewildering. There's a lot of jargon. People talk about all of these different types of metrology and blocks and measuring tools and cutters, and it's helpful to just see what this stuff looks like so you know what you're looking for when you then click away from Amazon and go to a reputable tooling supplier and buy the good quality version of the thing that you saw now that you know what they look like. And also lots of the stuff, as I said, that I link to is perfectly fine. Buy your parallels and your 1, 2, 3 blocks on Amazon. They're fine. Related to the last one is beginner mistake number 5, which is don't buy cheap metrology. I separated this out because it's extra important. I think metrology is an area where beginners often cut a corner because, let's be honest, a good quality micrometer or dial indicator is an investment. They're not cheap. And you know, you look at one of these discount tool supplier indicators and plunger moves the needle, must be correct, right? But they aren't, and I'll show you why. I've set up this test, I think, as fairly as I can. I've tried to eliminate any cosine error, and I'm going to compare both my DRO and this high-quality dial test indicator from Mitutoyo to this discount tool supplier. I've actually given the discount supplier the more rigid indicator stand, so hopefully it should have a fighting chance. And let's traverse 1 inch and see what happens. The Mitutoyo is indicating exactly 1 inch of travel, and look at the it's actually down by 1/1000th. As you can see, the DRO is confirming within 2/10, so the Mitutoyo or the DRO might have some tiny amount of inaccuracy over that 1 inch of travel, but they basically agree, so that's a good quality indicator. But now, arguably even worse, watch what happens when I traverse back. The cheap indicator didn't go back to where it was, so it's inconsistently inaccurate. They both started at 0. This one went to 1 inch, this one went to 1 thou under, which, okay, maybe that's acceptable, but then when we go back to 0, this one went back to 0, this one remained 1 thou under, so it was actually more consistently 1 inch of travel on the way back. So there's something inconsistent happening in there. It's skipping teeth, or something isn't made quite right, and that inconsistency is worse. If an indicator is consistently a little bit out, you can learn to compensate for it, and it's usually going to be close enough over long travel distances anyway. However, when the accuracy is jumping around like that, that's a real killer. And the Mitutoyo, by the way, went right back to dead nuts 0. Quick side note, this is actually a lesson I just learned. If you've been watching my channel for a while, you know I've been using this indicator for quite a while, and I never checked it. I never checked it against an additional form of metrology like a high quality indicator or the DRO. And so I didn't actually know it was out, and it's been causing me grief for a long time. It just didn't occur to me. I fell for the trap of, well, plunger moves needle, so must be okay, right? And it isn't okay. It turns out that quality really matters on these delicate clockwork mechanisms. Who knew? Beginner mistake number 6. Don't buy tap and die sets for machine shop work. One of the most common questions I get asked is, what's a good tap and die set to buy to get started? And it's a perfectly reasonable question because, of course, taps and dies come in sets, and it would be nice to buy a set that has most of the basic sizes that you'll need all in one go and get you started on your journey, right? And I also thought that, which is why I bought this set. And let me be clear, for basic automotive work or DIY kinds of things, a set like this is perfectly fine. However, it is not good enough really for model engineering and machine shop work. The taps and dies in these things are usually carbon steel. They're not that good. They don't cut that well. They don't last that long. The truth is, when you really want to get serious about hobby machine work and model engineering, you need to buy good taps and dies. And for whatever law of the universe reason, good quality taps and dies do not come in sets. So the strategy that I recommend is, when you're getting started, you have a project you want to make. Maybe you've got some plans for a model engine, or you want to make a toolmaker's clamp or something for your first project. Look at all of the threads you're going to need in that project and buy the die, the taper tap, and the bottoming tap for that thread, and for each of the threads in that project. Buy those 3 things. Even if you don't need all 3 pieces of tooling for that thread pitch, buy all 3 of them. It's a small cost. You can buy good quality ones. You're spending maybe 10, 20 bucks each for each of those. So it's a modest cost, and it's spread out over time. For your next project, do the same thing, do the same thing. And you're going to be buying 2 or 3 tap and die sets for each project that you do. And within 6 or 7 projects, you're going to have 90% of the taps and dies that you need, and they're all going to be high quality. Of course, you don't get the nice storage box, so you're going to have to find some way to store and organize all of your loose taps and dies that you're buying. This is how I happen to do it, drill some holes in a board. But there's lots of different ways people do this. However you want to do it is fine. Just don't put them in a drawer. Don't have the taps banging into each other in a drawer, because they'll get dull very quickly doing that. But find some way to organize them that you like, and over time you will have all the taps and dies you need. As you can see, this isn't a huge number, right? Each of these is tapping and bottoming in each of the threads that I use, and I've got every metric and imperial thread here that I need. If you're only working in metric, then obviously you don't need all the imperial stuff, even better. And I'll note that you don't need plug taps. Bottoming and taper are good enough. Plug taps are kind of a middle ground that honestly I'm not even sure what the point of them is. If you need threads to the bottom, use a bottoming tap. If you have a through hole, use a taper tap. End of story, you don't need plug taps. So 2 of each thread on the taps and then the matching die, and you're good to go. Sort of a beginner mistake 6A, buy round dies. Dies come in different shapes, mainly round and hexagonal, and buy the round ones because the round ones are much easier to make your own tooling for, such as a tailstock die holder for your lathe, which is a very useful thing to have. You can also easily make your own die stocks for them. That right there is my shop-made die stock for 1-inch dies, and that's much easier to work with as a hobbyist. There's a common misconception that the hexagonal shaped dies are only thread chasing dies for repairing threads. That's not true. Hexagonal dies come in repair, rework, and fresh thread cutting forms, but just don't buy the hexagonal ones. Again, I am aware of the irony and hypocrisy of the fact that this set is in my affiliate links. And I bought this set back when I was working on cars, and for that purpose, it's honestly a great set. It's got everything you're going to need, and it's got a nice ratcheting die stock and adapters and things. All the taps are in the lid here. I've actually moved the better of the taps into my storage system there. So it did kind of get me started a little bit, but if I were to do it all over again, I wouldn't buy a set like this. Also, because these are hex dies, I can't use these in any of my shop-made tooling, so I do still use it, and it's linked in my description. If you're just a DIYer or you're just working on cars, it's still a good set. But I don't necessarily recommend it as a way to get started on your tap and die journey in hobby machining. And we'll finish on kind of a silly one. Don't use magnets for stuff in your hobby machine shop, she says as she pulls a magnet off of her DRO mount. This is one of those things that beginners often get really excited about, that everything in a machine shop is metal. And so you can use magnets for everything, right? Magnets to stick stuff to stuff, and you can use magnets for mounting everything and put magnets on all your stuff. Magnets, right? No, magnets are actually a really, really bad idea most of the time in most places in machine shop setups, because they attract chips. And when chips stick to magnets, it's very difficult to clean them off, and they become extremely annoying when they're covered in chips. I'm counting this as one big hypocrisy, but arguably there's lots of little hypocrisies here, because you see me using magnets in lots of little places. But this is what happens to them. I wanted to show you this. You can see that the chips get stuck to them, and the chips get magnetized to them, and the magnets actually get weaker because the chips get stuck under them, and then they fall off, and then they ball up a bunch of chips wherever they land, and they're difficult to clean off, and it's a huge pain in the bum. There's a few things you can do to mitigate this. One thing I have done is put painter's tape over the magnet, and then when the chips stick to it, you can just kind of peel the tape off. Or with gloves, you don't want to touch them too much because they're sharp, but with a glove on, you can sometimes scrape the chips off into the trash. The other reason to avoid magnets is if you use magnetic DRO scales on your machines. The instructions for these, by the way, explicitly tell you this, but most people don't read the instructions. You have to keep magnets away from these scales, or you can damage them. They're essentially linear floppy disks, and if you get a magnet near this, you're going to mess it up. All that said, there's a few places that I do use them, like we all do. One of them is here on my shaper. I use these magnets to hold a piece of acrylic that acts as a chip shield. And I mostly cut brass on the shaper so the magnets don't get too chippy, although you can see there's currently a mess on them now that I'm going to have to deal with at some point. The other place I use them is, as you saw on the backs of my machines, I have a place to hang drawings with a magnet. And it's very, very handy to have your drawing just out of your sight line when you're working on the machine, so you can constantly glance at it and triple and quadruple check your dimensions as you're cutting. That saved me a lot of grief over the years. And these are okay because they're way up and in the back, kind of out of the way. They don't tend to get hit by chips, so the chips don't stick to them. But I mean, even still, they get the occasional rogue chip on them, as you can see here. And of course, we all use magnetic indicator bases, and these are among the greatest of human inventions ever, because a magnet that you can effectively turn on and off is a freaking miracle. And I mean, there's no better way to mount an indicator stand. So these are an unadulterated win. You should buy as many of these as you can afford and put them everywhere. But these are kind of an exception because they have the ability to effectively turn off by rotating the magnet out of the flux orientation, something science. So if they do get chips on them, which they do, anywhere you put these, they're going to get porcupined up with chips by the end of your cut. You just turn them off and the chips all fall off. It's magic. It's great. But again, don't put these too close to your magnetic scales. How close is too close? I don't know. I've never found out, and I hope never to. Well, there's a bunch of opinions worth what you paid for them. I hope something in there was maybe helpful for you. Again, I don't want any of that to be seen as a criticism if you are doing some of the things that I just said not to do, but it's working for you and you're enjoying yourself, then that's all that matters. Again, no wrong way to hobby. These are just my opinions. Maybe they'll be helpful. Well, thanks so much for watching. Thanks to my patrons for making all this happen, and I'll see you next time.